Good afternoon, and a warm welcome to everyone present here today. Thank you for joining us. My name is Kaushik, and I will be your host. Today, we are bringing in a special episode from SYTRAK RTLS, the flagship product line from Krishworks Technology Innovations, demonstrating our intelligent asset power, tracking, and accountability device. Please allow me to introduce Active Asset Accountability System, or the A3S Node. We will learn how SYTRAK RTLS can help to provide visibility into real-time location and energy consumption of an asset, allow remote power control of the asset, as well as allow easy transfers of the shared asset between project teams without invoking time-consuming stores procedures. All of these via a single window A3S node. We are demonstrating typical scenarios within an industrial lab or the office setup, wherein we will state a high accuracy 2D RTLS of 10 to 30 centimeters accuracy, real time movement of the shared assets, monitoring the energy consumption of an asset, allowing remote power control to turn an asset on or off, as well as an RFID based asset transfer between two individuals. Let's understand the system components a bit here. We have a typical shared asset, which is an oscilloscope device used in a lab or industrial setup. We have our flagship A3S node integrating four features within it. It is a UWB RTLS tag, an energy monitor, a remote control, as well as an asset transfer device. The third component, which is the RTLS dashboard of SYTRAK. Let me explain the dashboard a bit. We are sitting inside a conference room layout wherein the four anchors are mounted at above head heights and given friendly names like top right corner, bottom right corner, and the like. And for the demo, we will monitor only a single oscilloscope asset via the A3S node. Let's see the assets anchors in action. So we have the four anchors inside this conference room at above head heights. These are powered devices. And now we will have a look at the RTLS part. The oscilloscope is attached to the A3S node and its live location is visible within the conference room. As my friend moves around the room carrying the portable asset in her hand, the dashboard shows real-time positioning of the asset, demonstrating live location visibility. She is walking along the edge of the room from corner to corner, and the dashboard accurately captures the movement within high precision of 10 to 30 centimeters. Now let us look at how the energy monitoring and remote power control works. The oscilloscope asset is powered off initially and there is no energy consumption. The status is visible in the dashboard as off and the live energy graph is flat. As the oscilloscope is manually powered on, the dashboard will instantly capture the state and change the status to on. And a little while after, the graph will come alive. The power consumption of this equipment roughly stays at 43 milliampere for a 220 volt supply. And you can see how the oscilloscope asset and the A3S node is attached. It's like a simple power plug. The white wire and the adapter belongs to the oscilloscope and the black one from the A3S node. So it's like a simple power plug. Now we will demonstrate turning off the device remotely. We will press the turn off button on the dashboard and the power supply to the asset is cut off through the A3S node. There you go. The oscilloscope is powered off. Now we will look at the digital transfer in action. The entire setup is powered off and my friend is trying to do an asset transfer. ownership transfer. This works because the A3S node also has a battery backup so that the live positioning and traceability can be performed even when it is not connected to the power supply. Coming back, as you can see, my friend is pressing the button. Currently, the oscilloscope is under the ownership and accountability of Angel, as you can see over here. Okay. My team says there is a technical issue. I will take it back and replay the video. Four corners of the room. These are power devices and the four corners of the conference room. Let's now look at the RTLS part. The oscilloscope asset is attached to the A3S node and its live location is visible within the conference room. As my friend moves around the room carrying the portable asset in her hand, the dashboard shows real-time positioning of the asset, demonstrating live location visibility. She is walking along the edge of the room from corner to corner, and the dashboard accurately captures the movement with high precision of 10 to 30 centimeters. Now let's look at the energy monitoring and remote power control. The oscilloscope asset is powered off initially and there is no energy consumption. The status is visible in the dashboard as off and the live energy graph is flat. As the oscilloscope asset is manually powered on, the dashboard instantly captures the state and changes the status to on. After a little while, the graph comes alive. The power consumption roughly stays at 43 milliampere for a 220 volt supply, and you can see how the oscilloscope asset and the A3S node is attached together like a simple power plug. There you go. The white wires and the adapter are from the oscilloscope and the black ones are from the A3S node. Now we will try turning off the device remotely. There is a turn off button within the dashboard, and once we turn it off, the power supply to the oscilloscope asset is cut off through the A3S node. There you go. The asset is now turned off. We will now look at digital transfer in action. The entire setup is currently powered off and my friend is trying to do an asset transfer. This works because the A3S node also has a battery backup so that live positioning and traceability can be performed even when it is not connected to the power supply. Coming back, currently the oscilloscope is under the ownership and accountability of Angel. As you can see it over here, a switch is pressed to initiate the transfer menu. Let me read it out. It says the employee ID, and thereby it says to transfer, tap the RFID of Angel. She is tapping her card, and then it says RFID detected, tap the second card. The second card is tapped, and it says fetching details of the second card, then a bunch of text about transferring, and there you go. The dashboard states correctly the asset is transferred from Angel to Sona. Store procedures are time taking, and what we have seen is we walk up to the department followed by signatures and records, and then my colleague comes to me and says, I need it for an hour while you are at lunch. I can't refuse. I'll appear rude. But over time, this cycle repeats and assets exchange hands. And later on during inventory, records will state that the asset is under accountability of Kaushik, but Kaushik has no idea where it is currently, who is using it, how many hands it has exchanged, and what is the wear and tear condition of this asset at present. That's just how things work. But my A3S friend over here can help a lot of people overcome this situation, and the store managers can breathe a sigh of relief. There is another interesting feature of SYTRAK RTLS which is very helpful, and that is smart alarms. It works in conjunction with the A3S node. Typically, such oscilloscope assets are to be turned off while exiting office. But as human behavior, sometimes people leave such devices powered on, leading to increased usage wear and tear. Now, using A3S node and smart alarms, device can be configured to turn off after working hours. Sort of like in many Office IT policy, some dev environment AWS EC2 instances are automatically turned off after 8 p.m. or so to save billing. The same can be achieved here through the A3S node. Let me do a walkthrough now of the entire system for better understanding. Here we have the active asset accountability system or the A3S node, which will allow anyone to monitor, manage, control shared high value assets with complete transparency. Let's see why it is needed and the problem statement of the industry. We have lack of asset visibility. The high value assets are moved without tracking. There is no real time location visibility, and it is difficult to identify the current user or the owner. The manual asset transfer procedure requires physical visit to the shop floor or the stores for reassignment, and the delays and dependencies are available or manual entries. And there is no usage logs on energy transparency. There is no monitoring of the asset utilization. There is no tracking of energy consumption, and there is no remote control of the connected loads. The existing or the alternate solutions, we have the traditional asset registers wherein the manual entries are made, which are error prone and time consuming. We have basic energy meters for energy consumption, but they measure consumption only. There is no asset tracking, and mostly there are no load controls. And for standalone RTLS, the location tracking is available, but there is no energy monitoring or there is no asset transfer workflow. So all the existing solutions solve parts of the problem, but none of them solve it completely. So our approach to the existing problem is one device with multiple capabilities, which have high accuracy RTLS of 10 to 30 centimeters. We have a digital asset transfer between user to user without invoking stores procedures. We have the remote load control to turn an asset off or on. We have the energy consumption and monitoring. So, which eliminates manual dependency, it provides complete visibility, control, and accountability. The features of A3S node are, like it is said, high accuracy RTLS of 10 to 30 centimeters, the remote load control to turn on and off an asset, digital asset transfer, and energy consumption monitoring per asset. The core capabilities will allow anyone to track who is the user of the asset, track where the asset is located, track how much energy it has consumed live or historically, and control it load via remote on or off or smart alarms. In action, the scenarios would include a shared industrial asset across multiple users, and the asset moves across different users and locations. There is no real-time visibility and no control over how and when it is used. Let's look at the first use case, which is where the asset is. The capability should include live location and the traceability or the trackability. So where the asset has moved across the facility, even historically, like in the last 30 days, where and all this asset has moved. The problems it solves are, it eliminates guesswork in locating assets, it reduces time spent in searching for equipments, and it provides instant visibility on asset location. Let's look at the second use case, which is how the asset is being used. The capabilities include live energy consumption. and the usage insight per asset. The problem it solves are it identifies how much energy consumption each asset has done. It detects inefficiencies or idle usage, so which means someone has allotted the device from the stores to himself or herself, but the device is lying idle for a long time, and it enables better energy optimization and cost control. The third use case, which is taking control of the asset. So if the device is idle but still powered on, so we can remotely switch it on or off and control the asset usage in real time. The problem it solves would be eliminates need for physical intervention. It prevents idle energy consumption, and it enables instant response to misuse or downtime. The fourth, who is the ownership or the accountability of the asset. The assign assets directly to the users digitally between one to another user and maintain accountability and traceability. The problem it would solve are clearly identify the current asset owner. It eliminates manual tracking and disputes, and it ensures complete responsibility and audit trails. So thereby, for an asset, we can understand where it is, who is using it, how it is performing, and who is responsible. There are few variants of the products related to one phase, like a single phase measurement or three phase measurement, as well as load control is required or not required. Some industries may not require load control. So thereby we have few variants of the products. So we go from monitoring to control for tracking, monitoring, controlling, and assignment of an asset in real time. Now that we have gone through demonstrations, we will now take questions from our viewers. Nitish Kumar Singh, why do you think most organizations stop at visibility and don't move towards control and accountability? The problem exists in the industry, but the solutions which are provided would require a combination of multiple things. Now, any new technology or a solution which is introduced requires people to get used to it. If there is a single window to achieve all these things, people are inclined to use it. But the more number of tools which gets added, people get a bit hesitant to learn more things for every new thing. So while it is needed, easiness of use also matters a lot, and that is why we see the industries do not move towards control and accountability. Next question, please. Mr. Pupala Virendra, do you think having real-time accountability actually changes how people use assets on the ground? Yes, a lot. For example, we see an asset which has been issued from the stores to an individual, and that individual may be using it or may not be using it. And the colleagues around or the teammates around, as human behavior, if something is right in front of me, everyone wants to avoid stores procedures or right compliance and just take it for a small usage. Maybe it's a 1 hour use, maybe it's a half a day use. So thereby what happens is, if the accountability is not under an individual, the responsibility decreases a bit. People, it is individual dependent. People who are responsible may use it responsibly. People who are not responsible may abuse intentionally or unintentionally. But if the accountability is under you, you will always be under an impression that yes, I have to respond if questions are asked to me about the wear and tear or the safe usage of the equipment. Next question, please. Mr. Noah, how scalable is this approach when deployed across large facilities or multiple locations? So the approach is highly scalable. So if we talk about typical facilities of 40K square meter or 100K square meter, so we define coverage area, like across a large industry. I need to track the production area only, because my equipments or my target materials move only in the production area. or someone wants to track the loading area, the docks, like when the actual goods or the finished goods are moving from the production floor to the docking area for packing and shipment, that is the area where I need to track more. So we just cover an area, cover the target area with grids, cover the target area with anchors, define zones, define boundaries, and then just attach such smart tags like the A3S node to the equipments or the assets, and then it covers the whole locations. Now it can work across a single facility or multiple facility as well. So the approach is highly scalable, Mr. Noah. Hope that answers your question. Next question, please. Mr. Jagan, what kind of inefficiencies or losses can companies reduce using the A3S node? One thing is the traceability and the trackability. So what happens is end of the year or start of the year, when the inventories are being done by the store managers, physically each and every asset needs to be known, that okay, which asset is where. So over a period of time, such issued assets may be not lost but misplaced, like it has moved from one department to another, it has moved from one individual to another. The individual whom it was issued to is maybe on a long leave, he or she has kept it on a desk or on a cupboard, and the other persons in the team do not have visibility of where the asset is, and it is needed urgently. So in typical scenarios, the traceability plays a very important role. If I know that, oh, my asset is here, then it helps to find things very easily. And the second is the energy consumption. Now the asset undergo normal usage, wear and tear, that is fine. But if we use it responsibly, every individual, like turn it off, or we do not keep it to an individual and apply smart alarms that okay, it's 8 o'clock, most possibly everyone has left off for the day. If such smart tags are seeing energy consumption, then they just turn it off after 8 o'clock. Or like the transfers, like I explained earlier, that usually stores visit is something which everyone dislikes, whatever the case may be. So one individual can easily transfer to another individual, thereby giving a relief to everyone, the end users as well as the store manager, because the accountability is live now. Hope that answers the question, Mr. Jagan. Mr. Ashish Kumar, how does the system help in assigning ownership and accountability? So assigning ownership starts from stores when it is issued. Now, the first time such a system is live, so if an oscilloscope or an asset is assigned to someone, in the records we can assign that Mr. Ashish is the owner of this asset. But Mr. Ashish may not require it after, let's say, a week. Now, after a week, Mr. Ashish has the option to either go back to the stores and return it back, or if someone needs it instantly, then and there, the other individual can do simple transfers and take the ownership and the accountability under his or her name. If the assets are low in numbers, that is usually not a problem for stores manager. But if in an industrial setup or defense setup or a laboratory setup, there are large number of assets, you have thousands of assets, then it's suddenly a very big headache for the stores managers. That is where such easy transfers play a big role. Hope that answers your question. Next one, please. Mr. Sharath, how does your system handle signal interference and multipath issues in dense industrial setups? So, like I said, this is a UWB RTLS tag, which is having high resilience to multipath and dense industrial setup. Let's talk about automobile setup a bit, which has a lot of equipments, which has a lot of metallic structures. Maybe there are racks which are available. Now, these anchors can have a ceiling mount as well as wall mount. If ceiling mount is possible, where we are seeing a particular asset or we are seeing the coverage area from a high mount, The technology would allow, so UWB is a very superior technology when compared to traditional technologies like Bluetooth. So the superior technology would allow good penetration, good refresh rates, and in a very high hertz environment, the UWB technology itself would handle the interference and multipath issues. Hope that answers the question. Next one, please. Mr. James, in an office or lab setup, where do you see the biggest impact of the system? Uh, in a lab setup, the typical example can be we have the oscilloscope. So they are very common in laboratory environments. And in office, depending on the type of office it is, if we have shared assets particularly, shared assets are will have the most benefits of such a system to track where it is and to allow easy transfers between project teams. And that is where the biggest impact of such a system will be, Mr. James. Next question, please. Mr. Maheshwaran, how does A3S Node combine tracking with energy monitoring? So the device itself is built in a way that it can function both as an energy monitor as well as using UWB technology, allow itself to become a smart tag. Now, if the area is covered via anchors, so the anchors can easily see the tag and report it to the RTLS system on the premise. And the relays and the equipments or the sensors within the device can also report the energy. So the device itself is created in a way to act as multifunctionality single setup. Hope that answers the question. Next one, please. Mr. Omkar, what makes A3S Node different from typical RTLS or IoT tracking solutions? The typical RTLS would provide the tracking, it would provide traceability, but most of the traditional RTLS systems would not tell you the energy consumption of a particular asset. It would not allow quick, easy transfers for the shared assets. So for these two reasons, this just sets aside itself apart. The traditional energy meters, it can tell the consumption of an entire section, but per device energy consumption is typically not deployed. And it can also not do remote power control. Like, okay, we have identified that there is a device which is consuming unnecessary power, or there is a device which has been idle for a long time. Can we do something remotely, or some intervention needs to happen physically? So that is where things are A3S Node keeps itself apart. So I think we do not have any more questions. A big thank you to all of you for tuning in and engaging with us today. We will be back soon on more demonstrations of SYTRAK RTLS. Please don't forget the replay will be available on our YouTube, LinkedIn, and Facebook pages. I am Kaushik, and on behalf of everyone at SYTRAK RTLS, thank you for joining our talk on demonstration of our A3S node, an intelligent device which provides high accuracy RTLS positioning of 10 to 30 centimeters, an energy monitor, a remote control, and an asset transfer device all baked into one. See you again at our next session. Have a nice day.